Diving into the world of mathematics, let's talk about differential equations. They're like the detectives of math, helping us understand how things change over time. From predicting population growth to modeling the spread of diseases, these equations are the backbone of many scientific discoveries. By studying their behavior, we unlock the secrets of the universe and pave the way for groundbreaking innovations. So next time you see a differential equation, remember, it's not just numbers and symbols. It's the key to unraveling the mysteries of our world.
Hello everyone, আশা করি তোমরা সবাই ভালো আছো. This is my first class for bachelor level students, and the topic's name is a differential equation, which is the one of the most important chapter for mathematics, you can say. And those who are studying right now in engineering university, everyone has these types of course like engineering mathematics or differential equation or complex number or probability, something like this. There are so many names, but here at my university they have the course engineering mathematics. The name of the course is engineering mathematics. So it doesn't matter of fact, the main thing is a differential equation is a common topics for all engineering students, as well as those who are studying in other courses, like those who are studying in physics or mathematics. They also have these types of course, these types of topic. So we can start now. What is called differential equation? A differential equation means where in an equation there is derivatives. This is called differential equation. So derivatives means we know dx of y, it's a derivative, right? So when a derivative involves in an equation, then this equation is called differential equation. In a differential equation where there is only one variable, then this is called ordinary differential equation. Only one variable exists. Like if you consider this equation, you see here only x is your variable. You can say y is also a variable. No, y is a dependent variable. Basically we are talking about the independent variable. So x is your variable here. That means this equation only one variable exists, like x. That's why we can say it's a ordinary differential equation. So ordinary differential equation means where there is only one variable exist, then this is called ordinary differential equation. Then if I talk about the partial differential equation, where partial derivative exist, partial derivatives, you know, remember when you were in class 12, then you learned this one, del x of y. When you learn gradient, divergence and curl, then it was there, right? So when it involves, then these types of equation called partial differential equation. Okay, so now we will learn how to describe the ordinary differential equation. So first of all, this is called first order differential equation. What does it mean? Here the power is 1, maximum power is 1, that means it's called first order differential equation. It's second order differential equation, it's third order differential equation, because highest power is 3, highest power is 2. So according to this power we can call it according to this order. Like if it is the maximum power is 4, then we can say it fourth order differential equation. Okay, so an ordinary differential equation can be written as f x y ddx of y, this is called y, nth time differentiation of y with respect to x. So we can signify any ordinary differential equation in this general form, every ordinary differential equation. So there are different types of differential equation. First, if I talk about two types of differential equation, one is linear, another is non-linear. It is so easy, but you have to understand what I am talking about. So a differential equation is said to be linear if dependent variable and its derivatives must be in first order. One thing remember, dependent variable and its derivative must be in first order. That means in a equation your dependent variable and its derivative always be in first order, not in second order, third order, like this, first order, always be in first order. Second rules, no products involving the dependent variable and its derivative. No product, that means there will not be any multiplication between the dependent variable and the derivatives of that variable. Dependent variable and the derivatives of that dependent variable. Like for example, I am giving you the example always. So if I talk about this one, what they are talking about, we can describe it here a little bit. A dependent variable. Let's see, your dependent variable is y. Okay, so dependent variable and its derivative must be in first order. Dependent variable y and dy by dx, they always be in first order. That means it is not possible. If it exists in a differential equation, then it will not be a linear differential equation because it should be in first order. Okay, if I write like this, if it is exist in a differential equation, then it is not a linear differential equation. Because of why? Because there is a power. It should be first order. Okay, I think you understood what I am talking about. Like what does it mean by first order? What does it mean by first order derivatives? No products involving the dependent variable and its derivative. No product, that means y dy by dx. Product, if it exists in a differential equation, then we can't say it's a linear differential equation because no products involving the dependent variable and its derivative that means y into dy by dx, if it exists in a differential equation, then it's not a linear differential equation, it will be a non-linear differential equation. I think you understand. No non-linear function of dependent variable, no non-linear function of dependent variable, no non-linear function. So what is called non-linear function? Non-linear function where the path of the function or the line of the function are not straight, like sin x, cos x, e to the power x, log a base x, all what I told right now, all functions are non-linear function like sin x, cos x, tan x, then e to the power x, all are non-linear function. So no non-linear function of dependent variable, not the independent, of dependent variable, that means sin x, sin y, cos x, cos y. If I consider x is your independent variable and y is your dependent variable, then it's good, it's okay, no problem, because here it is stated that no nonlinear function of dependent variable. That means if any differential equation sin y or cos y exist, then it is not called a linear differential equation. But if sin x and cos x exist, then I can say, then there is no problem. The problem is when sin y and cos y exist. This is the, remember, this is the main important thing. Why? Because they are the dependent variable. So I think in a simple way, if I say it's a nonlinear function of dependent variable, it's a non-linear function of independent variable. So it's okay, but it is not okay. So remember, keep it in mind. So there is 5 examples I have given. I think you can easily understand right now. So first one, sin y dy dx of y plus y equal to 2. It's a non-linear. Because of why? Because there exists sin y. And from my equation, you can easily understand which is independent and which is dependent. Always remember, if I write a function like this, dy ddx of y, which one is independent? This one is the independent variable. This one is the dependent variable. Right? Right. So if I write like this, d dt of x, that means what we call a velocity, differentiation of displacement with respect to time. So it's called velocity, we know. So here x is your dependent variable and t is your independent variable. I think you got my point. Which one is the independent and which one is the dependent? So we can say here x is your independent variable and y is your dependent variable. That means sin y, here sin y exists. According to the third law or third criteria, no nonlinear function of dependent variable is a nonlinear function of dependent variable. That's why it's not a linear differential equation. Okay, next one. It's a linear differential equation because sin x, no problem. ddx of y, y. First, dependent variable and its derivative must be in first order. This is also in first order. This is also in first order. That means it's a linear differential equation, LDE. In a short form, I have written LDE. This one is non-LDE, non-linear differential equation. Third one, d dt of x plus cos x t to the power 5. Here, x is your dependent right now. T is your independent. So first order, no problem. Cos x, you see here, there is no problem with this. Cos x, remember, this is the important thing. No nonlinear function of dependent variable. Cos x is a nonlinear function, right? And x is the dependent variable and x is the dependent variable. So according to this rule, there should not be cos x. So there is cos x right now. So we can say it's a non-linear differential equation, non-LDE. Okay. Fourth one, 100% it's a non-linear because first order, because there is only second order, non-linear, right? Okay. ddx of y plus cos y equal to 5x, linear or non-linear? Obviously non-linear. Because of why? Non-linear function of dependent variable according to the third law. According to the third. So I think you got a good information about what is called linear differential equation and what is not called linear differential equation. I think you got it, and I think you can differentiate between the linear differential equation and the nonlinear differential equation. Okay. Another term I will learn right now, one is called homogeneous function, homogeneous differential equation, and non-homogeneous. So what is called homogeneous? Like when in an equation the right hand side is 0, it doesn't mean the right hand side is equal to 0, it's a constant. The right hand side is a constant. So if I see d dx square y square, like means d second time derivatives of y with respect to x plus 4 ddx of y plus 5y equal to 0. If it is a function, you see at the right hand side there is 0, it's a homogeneous. But if there is not 0, there is another variable like 4 sin x plus 3 cos x, 4 sin x plus 3 cos x, it's not constant. Because of why? Because x is a variable. So with respect to x, the value will change, right? So we can say when this equation is equal to 4 sin x plus 3 cos x, then it's called non-homogeneous. When it is equal to 0, it's called homogeneous. I think you understood what I told right now, what is called homogeneous differential equation and what is called non-homogeneous differential equation or differential function. So right now we will go to our next slide. So I think you will understand easily this one. Okay, maybe it's, yeah, it's, you can see it easily. Okay, so solution of a differential equation. So right now we learn what is called differential equation. So how to solve a differential equation, or what is the solution of a differential equation. So I have given an example here. Let C is a real number, then a solution of a differential equation is this one. So you have to understand basically. So then a solution of a differential equation dy ddx of y is equal to 5x is y equal to 5x square divided by 2 plus c. Basically this is a equation, differential equation, right? It's a first order differential equation, we can say. And what is the solution of this first order differential equation? This is the solution. This is the solution. And you can say like, how I found this solution, how? So before that I want to show you something. Suppose if I ask you once like x square minus 5x plus 6 equal to 0. If anyone tell you like solution of this equation is 2, you don't know how he found the solution, you don't know, just you know that 2 is the solution. He told 2 is the solution of that equation. Okay, so how you can justify it? If you put the value here, 2 square minus 5 into 2 plus 6 is equal to 0. So it's 10 minus 10, 0. That means it's justify the equation, right? That means when you put x equal to 2 here, the equation is satisfied with 2. That means we can say 2 is the solution of this equation. Just do it first. Then we will tell you how to find out the solution of a differential equation. So what I told you, this is a differential equation and the solution of this differential equation is this one. So if you substitute the solution into the equation, if you put y, if you put it here and differentiate it, then you will get 5x, then you will get 5x. At the left hand side you will get 5x, at the right hand side you will get 5x. That means 5x square divided by 2 plus c, 5x square divided by 2 plus c is the general solution of the equation. Exactly what I told you right now. Just if you put it here, you will get here 5x. That means your solution satisfy the equation, right? So we can say 5x square plus c is the general solution of the equation. Okay, so how to find it? This is the way, this is the formula you have to understand. So I have given example for, this is the first example for differential equation. Later I will describe so many examples. I will take more classes on this topic. Okay, so consider a body has been thrown vertically upward. A body has been thrown vertically upward at time t equal to 0 and x equal to 0, because we know when you throw an object from the ground at the beginning time, the time is 0. At the beginning condition that there is no displacement, right? It's x equal to 0. I have considered this thing, and you know the gravity is acting along to the downward. Okay, so when you throw an object upward direction, the gravity is acting downward direction. So my acceleration is against the gravity, that means opposite the gravity, right? So the equation of motion, it's an equation of motion because it's motion like this is in dynamic condition. So we can write d dt of that means second term derivative of x with respect to t, d square is dt square is equal to minus g. Remember what is called acceleration. Here for this condition acceleration is g, but there is a minus sign because it's acting downward but you are moving upward. So I think you got it. So when you integrate the function, I think you remember when you integrate the function d dt of x equal to minus dt plus c1. C1 is the your error. Remember, this is the constant what we learned in our HEC level. So when you integrate it, it's a second derivative. When you integrate it, it comes to first derivative minus g. When you integrate it, you will get t only because there is nothing plus c1. You know, I think you know the equation of x to the power n dx is equal to, you know, the formula of integration, right? X to the power n plus 1 divided by n plus 1. I think you got it. Then if you integrate it again, you will get only x, because if you integrate it here, you will get only x minus g. If you integrate t, you will get t square by 2 plus c1t, because you have integrated twice. That's why you got another coefficient. So c2. So this is my equation of this. This is the, basically you can say it's a solution, because this is the equation. It's a second order equation, and you solve the second order equation step by step, and finally you got x. So this will be your solution of this differential equation. Now we will find out C1 and C2, because you don't know what is called C1 and what is called C2. They are the constant. So if x equal to 0, t equal to 0, thus this condition I will use. So x equal to 0, t equal to 0. If you put it here, you will get C2 is equal to 0. That means one constant is 0. Again, at t equal to 0, the velocity is u. One thing, when you throw an object, okay, then you have to, at the initial condition, you have to put some velocity, right? Because without the velocity, it can be able to move upward. So that means at the initial condition, I have considered the initial velocity is u. So if you put it here, if you put this here, C2 is 0, you got it. Sorry, I have used this here. T is equal to 0, d dt of x, because it is considered as initial velocity. No, not only the initial velocity, it is considered as velocity. D dt of x, when t equal to 0, the velocity will be u, right? Because at t equal to 0, the velocity is u. T equal to 0, the velocity is u plus c1. C1 is equal to u. That means you got C1 equal to u. U is your initial velocity. From equation 1, if you put C1 and C2, you will get, it is a solution of a differential equation like xt equal to ut minus half of gt square. Like what you learned when you throw an object in your HEC level, or in your, when you are in class 9-10, then you learned h equal to ut minus half of gt square. Basically the equation you can derive from a differential equation. And this is the way how to find out the solution of a differential equation. This is a normal approach, and the problem is not so much tough, but later we will solve so many difficult problems according to the differential equation law. So I think you can understand actually what is called differential equation, and how to solve the differential equation, and how many types of differential equation exist. There are a lot of type of differential equation exist, but I just described just the normal phenomena what exists, like in everywhere you will see it. So this is the way how to solve a differential equation. So আশা করি তোমরা সবাই ভালো আছো। আসসালামু আলাইকুম।